Welcome you all. I am Dr. Jagan, Associate Professor, Electronics and Communication Department from Rohini College of Engineering and Technology, Kanyakumari. So this video I have discussed about ADA wireless sensor networks. Hardware components. Sensor node hardware overview. When choosing the hardware components for a wireless sensor node, evidently the application's requirements play a decisive factor with regard mostly to size, cost, and the energy consumption of the nodes. Communication and computation facilities as such are often considered to be of acceptable quality, but the trade-off between features and cost is crucial. In some extreme cases, an entire sensor node should be smaller than 1 cc, weight considerably less than 100 grams, be substantially cheaper than US $1, and dissipate less than 100 in proportion to W. In even more extreme missions, the nodes are sometimes claimed to have to be reduced to the size of grains of dust. In more realistic applications, the mere size of node is not so important. Rather, convenience, simple power supply, and cost are more important. This diversity is notwithstanding a certain common trend is observable in the literatures when looking at typical hardware platforms for wireless sensor node. While there is certainly not a single standard available, nor would such a standard necessarily be able to support all application types, the section will survey these typical sensor node architectures. In addition, there are a number of research projects that focus on shrinking any of the components in size, energy consumptions, or cost based on the fact that custom of the cell components do currently not live up to some of the more stringent application requirements. But as this book focuses on the networking aspects of wireless sensor networks, these effects are not discussed. Controller. A controller to process all this relevant data capable of executing arbitrary code. Memory. Some memory to store programs and intermediate data. Usually different types of memory are used for programs and data. Sensors and actuators. The actual interface to the physical world. Devices that can observe or control physical parameters of the environments. Communication. Turning nodes into a network requires a device for sending and receiving information over a wireless channel. Power supply. As usually no tethered power supply is available, some form of batteries are next necessary to provide energy. Sometimes some form of recharging by obtaining energy from the environment is available as well. Example, solar cell. Each of these components has to operate balancing the trade-off between an as small an energy consumption as possible on the one hand and the need to fulfill their tasks on the other hand. For example, both the communication device and the controller should be turned off as long as possible. To wake up again, the controller could, for example, use a reprogrammed timer to be deactivated after some times. Alternatively, the sensors could be programmed to raise an interrupt if a given event occurs, say a temperature value exceeds a given threshold or the communication device detects an incoming transmission. Supporting such alert functions requires appropriate interconnection between individual components. Moreover, both control and data information have to be exchanged along these interconnections. These interconnections can be very simple. For example, a sensor could simply report an analog value to the controller, or it could be endowed with some intelligence of its own, pre-processing sensor data and only backing up the main controller if an actual event has been detected. For example, detecting a threshold crossing for a simple temperature sensor. Such pre-processing can be highly customized to the specific sensor, yet remains simple enough to run continuously, resulting in improved energy efficiency.